Welcome to the Stormsurf video surf forecast for the week starting Sunday, March 13th. Looking at significant wave heights from the North Pacific Ocean, we see one system, a gale, actually remnants of a gale, working its way into the Pacific Northwest. This formerly was storm number 12, producing 39-foot seas in the western Gulf, and swell from that system has hit the California coast. Buoys, pure swell that is, in Northern California are in excess of 10 feet at 18 to 19 seconds. Otherwise, not a whole lot is going on in the North Pacific Ocean, with high pressure expected to set up. Let's get into the details. We'll start out this week's tour with jet stream level winds. These winds up about 30,000 feet help support the formation of gales and storms. When those storms do form, help direct their track. We're looking for troughs. That is a dip in the jet. We see a little bit of one there. Little bit of one here too, in working its way into the Pacific Northwest. This is what was driving the gale that tracked through the Gulf of Alaska. We'll get into that in a bit. But we also see is a big split in the jet right here. Northern branch working its way through the Gulf, southern branch over Hawaii and into Baja. This supports high pressure down at the ocean surface, and that is not a good sign. That suggests weakness in the jet. That is not enough wind energy, and that is a classic symptom of the inactive phase of the MJO, which is now taking over the North Pacific Ocean. Even here, where the jet is supposedly consolidated a little bit, it is not very strong and looks like it's ready to split at any moment. Anyway, a little bit of trough here, trying to organize a little bit of a dip that would support counterclockwise flow aloft and down at the surface. That would be the hallmark of low pressure. And of course, low pressure makes wind. Wind makes seas. Seas, when they radiate away from the fetch area, produce swell, and swell produces surf when it hits your beach. Anyway, roll this out. We're into Monday. A little bit of a trough here. Tries to get organized over the date line. A little bit pinched. A little bit of winds here. 150 knots feeding it, but nothing too noteworthy. That trough, rather pinched off, continues into the western Gulf into Thursday. Notice high pressure takes over this area here, split in the jet, which would mean high pressure. Also, the same sort of thing going on here over the date line. Roll this out further. More split jet stream energy, but this trough here, not quite cut off, just a trough, but right on the verge of being cut off, continues, and then it finally does pretty much cut off a little bit here into Thursday, and it's just its own kind of low. Another little split in the jet here. You can just see this whole pattern of split tendency in the jet across the Pacific into Thursday and Friday. More like weak low pressure here, but just not a really well-organized trough into Saturday. And then Sunday, things looking a little better, but still the jet is split here. You want consolidated energy that would, or a consolidated flow that imparts more energy to the jet. And then when you get a trough, that helps really goose up storm production. We don't see that. A little bit of another trough here on Sunday over northern Japan. And then we round out here at almost into Monday, late Sunday. And the Gulf looks like the best potential area for gale development. But winds very weak here in the western quadrant where you'd want to see 150 or 160 knot winds. We see not even 100 knot winds. So probably not a whole lot going to happen. I think we're going into a bit of a down phase. Let's go down, look at the surface. So here we are down at the surface level wind, surface level pressure, and as expected, 1024, almost 1028 millibar high here, right in between where the jet is split. Low pressure as expected in the trough. What is that, about a 980 millibar low? Good amount of 30 knot fetch here in extending almost from the eastern Aleutians into the U.S. West Coast, targeting Northern California, Southern Oregon. Support for sea production, probably 12, 13 second period energy in this area at the moment as of 18Z Sunday. But looking back across the rest of the Pacific, nothing going on. High pressure here off the Kuril Islands in a rather slack pattern. We'll roll this out. Winds continuing in the Gulf into Monday. New gale develops off Japan. Tries to get organized. Pretty much gets shunted north. And finally organizes on Tuesday nicely. 50 knot winds there off of the central Kuril Islands, targeting Hawaii pretty well. A new system also that we saw in that tight pinch trough here north of Hawaii starts developing 35 knot winds. We get into late Tuesday night. 55-knot winds here now forecast off the Kuril Islands. That should be good for some pretty decent period swell radiating towards the U.S. West Coast and Hawaii. And now 35-knot winds here early Wednesday, targeting Hawaii pretty well. Roll this up some more, and then we get a little bit, this is interesting here, little shot of 50 to 55-knot winds aimed just a little bit east of Hawaii, but still directional spreading. There should be some decent swell coming into Hawaii, and also a bit into the U.S. West Coast. The gale off the Kuril Islands starts fading. We get into Thursday, the Gulf gale is the one that takes precedence or dominance now. 45-knot west winds pushing towards the U.S. coast, but it pretty much stays locked in, not moving a whole lot, just circulating in the Gulf, slowly fading out. Still fetch, 30-knot fetch into Sunday. Kind of interesting. Perhaps a good long run of medium-sized swell for the U.S. West Coast. And, of course, swell from the previous system we saw off the Kuril Islands for Hawaii. And then we get into 180 hours out. Low pressure still hanging, and bits of fragments of energy, but just there's a big 1028 millibar high starting to set up on the northern dateline region. Again, just not very, none of this looks like a very strong storm-producing pattern. But still, there is some activity on the charts. Let's go take a look at significant wave heights. So first off, we're going to go back in time a little bit till Thursday, March 10th. This is where the gale that went through the Gulf started organizing. Here we go. 29-foot seas. We're just looking at seas. We're not going to get into this too much. We see peak seas right about there in the 39-foot range. Relative to Hawaii, notice most of this is cutting across the Great Circle paths to Hawaii, but relative to Northern California, aimed pretty well right down the, what is that, about the 302-degree path, and we'll just roll this in. Continues on about the 302-degree path into Saturday, and then fades out off the U.S. West Coast, and here's pretty much where we are now into late Sunday afternoon. Still 20-foot seas out there. Looking at the YMA buoy, high-res buoy here, we're looking at spectral data. We see a little bit of energy. What's that? 3.7 feet at the peak at 14 seconds. That's as of, what is that, about 6 p.m. California time. And a little bit, here's an estimated surf height, probably about peaking out. We'll go down here, do a quick scroll down. We could see here, surf peaked out at about 10-foot Hawaiian. What's that, 6.5 feet at 15, 16 seconds on this morning in Hawaii. But clearly, much more energy into, we're looking at Point Reyes Buoy, Northern California. There's your swell, 18 seconds, right at the peak, 8 feet there. But you got to consider also the energy on either side of that peak. Projected surf heights in the 22, 23-foot range. We can work our way down here and take a look. You can see the swell started hitting. Here we go. Prime swell about 10 a.m. or so, 11 a.m. I'm sorry. 6 feet at 19 seconds built, peaked out right around now at report time, 12 feet at 18.5 seconds, 13 feet, 17 seconds. That's pure swell that strips out. So basically, if you go up here and look at it, it just considers this area under the curve right here. It chops out all this junk and chop and wind, because that is really what you're seeing hitting the beach now. This stuff it's just basically speed bumps on the much larger swell. Anyway, we scroll down here again. Surf heights in the 20, 22-foot range. That's probably about right. A very choppy mess, but there's good solid surf hitting Northern California at this time. And so that swell that is hitting, that is the 12th significant class swell of the season. Pretty respectable. Putting things in perspective from an El Nino perspective, that is. During the big 97-98 El Nino, there were 39 significant class swells, so we're at about a third of that. And that makes about sense given everything else we've seen this season so far associated with this El Nino. So anyway, looking at the significant wave height charts, we see our system working its way into the Pacific Northwest, fading out. Next system scheduled, as we saw on the surface level charts, off of the northern Kurils, Tuesday Tuesday evening into Wednesday. Now, this is a bit of a bump up from what we saw previous runs. Now 48-foot seas up here and aim pretty well down the Great Circle paths to California and Hawaii. We'll roll this out. That system fades out, but then we have our other system north of Hawaii, and we'll actually go back. You can see, what is that, 20, 22, 25-foot seas, almost aimed dead at Hawaii, and then slowly working its way into about the 34-foot range, 34.7 in one little grid square there. And again, sending a good amount of sideband energy towards Hawaii, but also towards the U.S. West Coast, probably favoring Southern California more than Northern California. That gets us out till Friday. That system continues out there with 20, almost 25-foot seas. That should be a good long run of 13 to 14 second period, maybe even 15-second period swell for the U.S. West Coast and sideband energy into Hawaii. And still at 150 hours out, it's there. And we're getting to, there we go, to 180 hours out, it finally dies. So a good potential long run of swell. And the thought is improving local wind conditions. This rain and south wind mess is going to pretty much fade out. In fact, let's go take a look at that real quick. So here we are, precipitation. We're really looking at California here. You can see snow in the Sierra, rain into California, but we'll roll this out. We get into, what is that, Monday about 10 a.m., and things really dry up. Here's our high pressure. It starts ridging into the coast. Roll this out, and basically that's the end of the precipitation. Here's our new system forecast for the Gulf. And does any of that precipitation make it to the U.S. West Coast? Well, by Saturday night, maybe showers, if you want to believe a model 162 hours out. It's not any strong indication of anything going on here. And then by 180 hours out, yeah, maybe a couple inches of snow for the Sierra, and that's about it. And here's our snow model for Tahoe. Here's Lake Tahoe right here, and you can see Squaw Valley, North Star, Kirkwood down here, Bear Valley, and then we also have the different, not cities, but interchanges basically along I-80 and along I-50, so you can sort of gauge where the snow level is. Currently snowing in the Sierra. We'll run this out, and you can see accumulations here for the various resorts. I'll actually put that back to here, and you can sort of see how this plays out as we go through each 3-hour segment into Monday. By Monday, 7 a.m., everything clears out. Accumulations, Kirkwood, Squaw in the 26-inch range. The same thing for Sugar Bowl. Less for Heavenly as usual, and the others. Basically, so 25 inches of accumulation is what is expected, and then basically we go into dry mode. And just one quick shot right now from the base of Sugar Bowl. Piles of snow accumulating on the tables here. Good sign. This is probably the last hurrah for solid snow from this El Nino, unless some miracle happens a couple weeks down the road. But this is pretty much it, and we'll get into that more in a minute. And so, long term, where are we going with our El Nino 2015-2016? Let's dive into the details, because that will give us a clue of not only what's going to come precipitation-wise, but also surf-wise. As always, we'll start our tour looking for westerly wind anomalies in the Kelvin wave generation area, which is really more than the Kelvin wave generation area. We don't even care about Kelvin waves anymore at this point. It's just looking for fuel for the jet stream, but it's the same area basically here. Here's the date line. Here is Australia, maritime continent, Mexico, South America. It is this box basically to, let's say, 5 degrees north and south of the equator. Going from about here, New Guinea, to the date line right in here. We see westerly anomalies right now. Well, this was as of March 7th. We'll just scroll through here, consecutive days, and some flavor of weak westerly anomalies are in play. Here's from the TAO buoy array. Here's actual winds on the surface. Again, the same area, basically from 135 east to 5. You can just draw a box right in about here. And what you see is easterly winds, strong easterly winds north of the equator. This sort of a patch of dead air there. Here's actual anomalies, and what you see is just this faint little hint of westerly anomalies, but basically nothing particularly indicative of a westerly wind burst or just barely El Nino. So here we go. Here's the Kelvin wave generation area. 3 degrees north and south of the equator is the main area, up to 5 degrees north and south of the equator. Date lines right here on out to 135. Basically what you see is what we saw in the other charts. Easterly winds north of the equator, but a big area of dead air south of the equator. And we'll just roll this out. This is a GFS model. And what we see is not a whole lot of change. Easterly winds north half, pretty much dead winds south half. And it is these dead winds here that are creating what would be, because normally you have easterly trades over this entire area this time of year. Because El Nino's in play, it has suppressed the easterly trades, mainly south of the equator. And so that results in a net out of what would be considered westerly anomalies. And then as we get into Friday, notice the easterly winds here north of the equator start really backing off. We'll roll this out a little bit further. We don't see any westerly winds at all. I mean, unless you see a couple little barbs here and there, but that's not enough to really get our attention. The interesting part here is, though, at 180 hours out, these strong easterly winds that have been in control up here are all gone or nearly gone by a week out. We don't think that's anything particularly related to El Nino or won't help support it or anything, but just something to note. And yet another way to look at westerly wind anomalies. So this is the whole planet on one chart. The equator is, the date line runs right down the center of the chart here. The Kelvin wave generation area is basically just a hair bit to the right of that, then over to somewhere around in here. We've had a good westerly wind burst. This was westerly wind burst number 6 for this El Nino. Started in mid-February, wrapped up about the 10th or so of March. And really good, strong actual westerly winds down at the surface. Most of this was almost south of 5 south. This area is supposed to be just 5 north to 5 south, but if you look at the GFS charts, I mean, most of the winds were south of even 5 south, but still westerly wind bursts nonetheless. And then the forecast for the next week basically shows, and it's reds, oranges, those are westerly winds. We see almost a hint of easterly anomalies forecast a week out. And of course, what's driving all this is the MJO. MJO, of course, Madden-Julian oscillation runs 3 to 4 weeks in the active phase and then flips over and goes to the inactive phase. We're most interested in this area in the West Pacific because when the active phase, that's this blues here, are over this area, that fuels the jet stream. That's what has been in play for about the past month. It has made for an amazing run of surf for a month or more now. And now as the active phase, it actually went south of us, and we'll get into that in a minute. That's what's creating the rain and the precipitation. But that quickly passed and is now reconsolidating. The blues are the active phase developing here in the Indian Ocean. Of course, the inactive phase here in the West Pacific right now. When we say things are sort of falling apart, this is why. Because the inactive phase, which doesn't support westerly winds in the Kelvin wave generation area, also steals fuel from the jet stream, causes it to split, and that's what we're seeing on the upper level charts. And that is not good for storm development and therefore not good for swell production and or rain or snow for the Sierra. So for the next 2 weeks, basically the inactive phase per the statistic model is to be pretty much over the date line. The dynamic model is giving us a little bit better picture here, and notice I'm keeping this last frame of the statistic model here, and the dynamic model are both suggesting this active phase that is currently in the Indian Ocean, and the inactive phase here starts moving off to the east, and then the active phase starts making progress into the West Pacific. That would be a very good thing if it were to happen. 2 weeks from now seems a little bit on the premature side. 3 weeks from now would seem more realistic. Phase diagram charts. So this is like looking straight down from on top of the North Pole, looking down at the planet. You have the Indian Ocean as you work your way around to the maritime continent, Indonesia roughly, over to the West Pacific over the dateline, into across the Americas, Atlantic Ocean, and then back to the Indian Ocean. This is where the core of the active phase of the MJO is right now, in the Indian Ocean. The further away from the center it is, the stronger it is, so it's quite weak. The forecast for the next 2 weeks, per this, the ECMF model, is to make it into the West Pacific, but be pretty much weak. The GEFS, which is the Ensemble GFS model, suggests it's supposed to make it to the maritime continent and then sort of retrograde and crash. So a little bit of discontinuity between the two models here, but generally speaking, the active phase is to start making its way off to the east. Whether it makes it to the West Pacific in 2 weeks seems highly doubtful, and let's go take a look at one more chart. So this is similar to a previous chart we saw. The dateline runs right down the middle of the chart. The the east of there would be here, west of there would be over here, east of there here. Now this one's a little bit different. This is going back in time, starting down here, November. Here was westerly wind burst number 5 that was in the January time frame. Westerly wind burst number 6. And the reds are really westerly winds. These oranges are anomalies. Okay, here is the current date. Here is the forecast. So basically, westerly anomalies don't start developing till about the end of the month, March 23rd. So that's 10 days from now, and then build the whole way through the month of April. Let's overlay the MJO. You can see where we are. So there was a strong active phase of the MJO here in December. Another pretty good burst that we're just coming out of here. It was in February. Now here's the interesting part. California about 122. So you can see the active phase of the MJO is pushing over California right now. That is why we've had this long run of precipitation here. A couple of weeks of solid rain and precipitation. This suggests that that's supposed to continue for about another 5 days, but I think that's being a little, maybe even 4 days. That's being a little bit generous based on what we saw. That doesn't mean that when you get in the inactive phase here, you can't have precipitation. Just the odds are not as good. And notice also that westerly anomalies die in the Kelvin wave generation area when you are in the inactive phase, the MJO. So things are going to back off for a little bit here is the net result. Precipitation is going to disappear. Storms are going to back off, which could be a good thing if you're into small surf rather than giant death surf. That's a good thing. But then come about, somewhere in about the late March, like March 28th, the storm machine's supposed to wake up again. And though we don't have the anomalies forecast as strong as what we got back here, still pretty good solid anomalies. This suggests a good long run of storm production in the dateline region. Now, wherever the MJO is the strongest and the west wind anomalies are, is where the center of storm production would be. So again, this suggests, mainly the dateline region into perhaps the western Gulf of Alaska, which is pretty much classic El Nino. So, and that would go from March 28th into, April 17th per this, but actually with these west anomalies out into almost early May, where we could have another good long run of storm production if this all goes as forecast. And then once you get into the May time frame, you're really into the end of the season, and beyond that, it doesn't much matter. So that's sort of the long-term outlook. Low pass. Let's take a look at low pass real quick here. So this is, relatively speaking, how your El Nino plays out. Here was the peak of El Nino pretty much in the January time frame. These contours here, 1, 2, 3, 4, 5. And now still holding solid, though, into almost the mid-May time frame, and then things really start weakening. Of course, this is a projection. You don't believe anything 2 months out, but it gives you some guidance and some hope of maybe what's to come. So in terms of Kelvin waves, which is kind of ridiculous to talk about at this point in the season, but we're going to do it anyway. Actual water temperatures, this is the West Pacific, this is the East Pacific. We're looking 2 degrees north and south of the equator and down at depth. We're looking for the presence of warm water moving off to the east. We see actually a good pocket here of still 29 degrees Celsius water temperatures extending to a point almost south of Hawaii. And the 28 degree isotherm used to be cut off right here at about 120. Even the last report, I think we talked it was there, but notice it's actually worked its way into the Galapagos now and beyond, which is kind of interesting, and we'll get into that in a minute. Anomalies. Now, if you recall from previous discussions, we had 4 or 5 degree anomalies in this area and lots of warm water. That's all fading out rather quickly here. Still, we have 2 degree anomalies on the dateline region, and basically it shows a break here, but we suspect that it's continuous the whole way in, and one last little pocket of 3 degree anomalies. But El Nino is winding down, so west anomalies in the Kelvin wave generation area we'll do it up here, take warm water that's normally all piled up here and start pushing it off to the east, and normally you have this 28 degree isotherm. It's deep here and very shallow, if not non-existent in the east. You see it's all kind of evened out across the entire Pacific now, and you can see why, because of the anomalies there. Also note, cooler than normal water here. What normally is over here is all over in the West Pacific now, but it is making serious inroads to the east. This is the beginning of the end of El Nino here. Now, it's not going to disappear in a day or two. It'll take months for this to happen, but it's about time that a normal balance in the ocean water gets restored. Another chart here, you can see this is the high-res view of that. Again, here's your cool water, but also note, because we've had westerly wind burst number 5 and westerly wind burst number 6, even though there's really not any warm water here to speak of, whatever there is still getting shunted off and pushed off to the east. We've actually got a little Kelvin wave, and you can see it right here, Kelvin wave number 5, and when we get to the surface chart, you'll see that it's actually starting to gurgle up on the surface here, and much further east than any of the previous ones. So this is actually helping to extend the life of El Nino. Not dramatic, no big deal, but still, it's preventing, at this time of year in 97, we already had cold water here gurgling up to the surface, and the beginning of La Nina was very evident. Here we are, March, and we look like we have 6 weeks at least, if not 2 months of warm water still in the pipe. So March, April. So we're talking warm water in some fashion around the Galapagos till nearly May, which is pretty impressive. Interesting, something to consider, but it will all crash at some point. More subsurface data, this from the Jason 2 satellite. This is looking for heights in the ocean surface. That is, strip out all the waves, strip out the tides, strip out the chop, strip out anything else, and deviations from normal. And wherever you see higher than normal numbers, not lower than numbers, higher numbers, this suggests warm water at depth. Warm water at depth, of course, because it's warm, it expands, it sort of pushes the ocean surface up a little bit and creates a bulge, 10 centimeters. 15 centimeters here, and this is very consistent with what we saw in the other charts, that there is warm water at depth in this region. And finally, our favorite chart here. So this was what? Kelvin wave, let's see, 1, 2, 3, 4. Yeah, Kelvin wave number 1 this year in the April time frame. Again, West Pacific here, East Pacific here. Reds are warmer than normal temperatures. Kelvin wave number 1 working its way across the Pacific. Kelvin wave number 2. Large Kelvin wave number 3 back in the August-September timeframe. Kelvin wave number 4, even stronger still in the October-November timeframe. Then we eked out Kelvin wave number 5 from westerly wind burst number 5. Okay, and that is pretty much done. Whatever's there, those 3 degree anomalies we saw right under the subsurface near the Galapagos, that's attributable to this guy here. And then you see these couple little pixels here and a little bit of weakly warm water here. That is Kelvin wave number 6. It's not even going to be a Kelvin wave because, as you see, we have cooler than water normal all over the West Pacific. You can take all the west winds you want and blow it across there, and all it's going to do is push cooler or normal water off. There just isn't any warm water left to create a Kelvin wave with, and that's typically how El Nino comes to its demise. It's basically all the warm water that it was over here gets pushed to the East Pacific, gurgles to the surface, trades pick it, and then it starts pick it up and start blowing it back to the west. And so that's where we are. the warm water pool is tapped out. So let's talk surface water temperatures. And here we go, deviations from normal for this time of year. So clearly, the El Nino signature is still in play. What we're really into is examining the micro details of that. Now, warm waters are not as warm as they were. This is all in the 3-degree range at one point, and specifically the Nino 3.4 region running from 120 to 170 and about it's 5 degrees north and south of the equator right there. Clearly, we're not as warm as we were, but the interesting point about this is right here, this pocket of warm water showed up. This is between 2 and 3 degrees above normal right in there. Let's see, 1, 2, about 3 shades. 1, 2, 3 shades, right about 3 degrees right in here. That is the furthest east this entire El Nino that we've had that warm of temperatures. Most of it has been all out in here. This region, when we say this El Nino was westward displaced, that's why. That's why we believe that the precipitation really didn't work its way into California as much as expected, because normally during a good major El Nino, you'll have warm water, but it'll be just totally, it's like this triangle that goes from here out to here and up to here. We never saw it. In fact, we had pretty much just slightly warmer than normal waters here. So the bulk of the heat was over in the Nino 3.4 region, which is great, but you have to examine the total coverage of all the warm water, and it certainly wasn't in Nino 1.2 and out in this area. It finally is now. Maybe that'll give us a little hope with the next active phase of the MJO. What is that, 3 or 4 weeks out? Maybe we'll get another good run of precipitation for California, but we're not holding our breath. But anyway, warm water is developing here now, late in the game, but it's here. Here's another way to look at it. Here's the Galapagos. Here's 2.25 degree temperatures above normal. Look at this warm water here off the coast of Peru. This is the first time we've seen this in probably months. It's not been particularly warm here. There's this cool finger that's been developed here, but there's warm water, and here's warm water west of the Galapagos out to about California would be about anywhere from 117 to 122. So in this region out to here. And now most of El Nino, this past El Nino, all the warmth has been out over in here. And finally, it's starting to look more like a semi-normal El Nino. But again, very, very late in the game and not in sync with the MJO. So the question is, well, how much of an effect will that have on precipitation to California? The question is probably not a whole lot, but we'll see. The last really gasp of hope is with the next active phase of the MJO. Differences in water temperature in the past 7 days, and you can see the warming here on this chart clearly in the region of the Galapagos. Mainly, so this would be Nino 1.2 and maybe Nino 3 region right in here. Here's a time series of the Nino 1.2 region between the Galapagos and Ecuador. You can see since December, temperatures have been on a steady downward shift in that area. And now, just recently, since the end of February, you can see temperatures working their way up to about 2 days ago. Now we're back down to about 1 degree or so, but we were up to about 1.5 degrees above normal. Nothing, if this was a major El Nino, you'd want to see this up in the 2 to 3 degree range. We're not seeing that, but still a little bit of an uptick. And here's the Nino 3. Region, peak temps right here, about 3 degrees in mid-January or so, and now we've been on this slow, steady decline, and that's pretty much what we're seeing in the surface charts. And then the Nino 3.4 region, this is where NOAA officially looks to determine whether you're in El Nino or not, and you can see our peak temps here. We're in the January time frame at about 2.8 degrees or so, and we've been on this slow, steady slide down to about, 1.8 degrees above normal. Still any other year you see this, you'd be very impressed, and we are impressed, but you can see that the demise of El Nino is setting in. The issue is, how quick is it going to come, and how long will it take to ride down, and the big answer is we don't know. So we've talked about westerly wind bursts, we've talked about the MJO, we've talked about the effect of those westerly winds in creating Kelvin waves, we've looked at the subsurface water profile, and we see that it is in a state of decline. We've looked at the surface water profile in the classic El Nino region, Nino 3.4 and also 1.2, and saw that for the most part temps are fading. Other than just west of the Galapagos, we seem to have a little bit of a resurgence. We think that is attributable to Kelvin wave number 5, miraculously, surprisingly, and so then, but all that means nothing. What's the effect of all this on the atmosphere? And so we look at things like we're looking for atmospheric coupling between the warm water on the surface and the effect on the jet stream. One way to look at that is the Southern Oscillation Index, difference in pressure between Darwin and Tahiti. Here's the daily index, and notice here we hit a peak low here on February 29th at minus 49.10. Clearly a sign. And another one here, minus 50.30, February 22nd. But you can see, just looking the past month, the values, the index has been very negative, and now all of a sudden it's getting positive on the daily basis. That is suggestive of the building in of the inactive phase of the MJO. The 30-day running average down to 23 right there, and now it's also starting to rise a little bit at a time. But still, the 90-day running average, which you use to look for El Nino, still quite negative, minus 15, clearly signs of El Nino in play. The atmosphere is reasonably well coupled, and the number of storms we've seen in surf and all that sort of suggests as well, but the focus has been more out towards the dateline, not so much at the U.S. West Coast in terms of where the peak storm generation is, and hence the lack of rainfall. And we think that's all attributable, again, to the westward displacement of this El Nino. Another way to look at this, there's another index we can look at, very similar to the Southern Oscillation Index, measures differences in precipitation north of Australia and then in the main Nino regions here. A positive number, today's value is 1.56, and it has been in that range, and if anything is going up, suggesting more precipitation in this area, drier here. You can see that clearly here. Here's just the rainfall anomalies for the last 30 days. Drier here, wetter here, but notice the core of the precipitation is just basically south of the western Gulf of Alaska. Not so much. Here's the U.S. West Coast. Not a whole lot going on in here. Again, westward displacement of El Nino. But the fact that this guy is up at 1.56, here we are into March, is kind of surprising. And we had been noticing this early. We thought this was going to be a long-lasting El Nino. Perhaps not so strong, but long-lasting. And it certainly appears to be that way. So a pretty good coupling with the atmosphere, still good potential for storm production and precipitation. Then one last thing we're going to look at, not so much related to the anything El Nino, but super long term, the Pacific Decadal Oscillation. Basically a 15 to 30 year cycle, sort of acting like El Nino or like La Nina, if you will. And we've been since, 97. Positive numbers represent I'll call it the active phase of the PDO. It's like a long-running El Nino. And at the end of the 97 El Nino, right out in about here in June, things started crashing. We got into negative numbers. We've been in this run of negative numbers here till 2013. And then notice all of a sudden, we started getting into a positive index, and we've been positive ever since then. And the current number here in February, 1.75. The question is, are we starting to run into another? So this was, if you go back here and go into somewhere about right in here, up to the 98 El Nino, all the numbers were positive. And that's suggesting a good long run. Actually, it went back. I thought it was into the 70s or so. But that was sort of a long-running El Nino, then a long-running La Nina. The question is, are we starting to now work ourselves back into another long-running El Nino or the positive phase of the PDO? I don't know. We'll need another year or two to determine that, but as of right now, the numbers are looking good. So to kind of put a bow on things right now, the last probably big swell, at least for the next couple of weeks, is hitting California. Of course, it's a stormy mess. Hawaii got some sideband energy from it. Nothing too outrageous. Weaker storm pattern forecast and weaker swell pattern for the next probably 3 weeks. And then, if everything goes as expected, the MJO will wake up again. The jet stream will consolidate. More energy will be imparted to it. The storm machine will wake up again, and we'll have another 3 or 4 week run of swell. And towards the end of that, with any luck, as the MJO works its way into the U.S. West Coast, we'll get another dousing of rain for 2 or 3 weeks or so. And then that will probably be the end of it. But by then, we'll be nearly into May, and one would expect the season to be wrapping up at that time. So that's it for this week. We'll do this again next week. Same time, same channel. See you then, and thanks for watching.